One of the main uses for data structures like an array list is to use it to search for a particular piece of data in a data set. By collecting them all into one structure, it makes it very convenient and efficient to search through that data set. In fact, most data structures, such as the array list, have built-in methods to help you with searching for particular items. So what we're going to do in this lesson is look at two of those built-in methods, index of and contains. And then I'm also going to show you how to search for a minimum value in the data set, or in the data structure, in this case in an array list. So let's start off by looking at index of and contains. First thing we need to do is create our array list. So we're going to generate some random numbers. So here I'm seeding the random number generator. Now I'm going to create the array list. Then I'll write a quick loop to initialize the values in the array list. We'll do 100 values for I 0 through 100 or through 99. Numbers add rand next int 101. The way we find an item in the array list is by using a method called index of. Index of will return the position of an element in the array list if it finds it. So what I can say is, I can say if numbers index of 100 is greater than or equal to 0, if it can't find it, it's going to turn -1. So if the number returned is greater than or equal to 0, then it found it, and then we can just display it, or display the position. Let's do that. Let's display the position. We'll say 100 was found at position, and here we just call the method again. We could have stored it, but this is just as easy. And I think that's all we need, so let's save the program. Then compile it, clear the screen. Java C, Cap 11, Part 7.java. And we see that 100 was found at position 24. And I have out instead of at, so I need to change that. Let's run it again. Need to recompile it since I changed the string. This time it found it at 12. Let's run it again. Found it at position 0, the first one. And so on and so forth. We could do that many, many times. Now another thing we could do is, rather than check to see if the index of the element we're looking for is greater than or equal to 0, we could just see if the item is even in the list at all. And we do that by using a method called contains. Contains is a Boolean method that returns true if it finds the argument in the array list and false otherwise. So here we can say if numbers contains 100, then write out what position we found it at, else write out 100 was not found in numbers, like so. So we'll save it, clear the screen, compile again, then run. Found at position 96, found at position 23, found at position 2, and there on the fourth try, 100 was not found in numbers because the contains method did not return true, it returned false. So the contains method will tell you if an element is in an array list, and index of will tell you where in the array list the element is. Now the last thing I want to show you in this lesson is how to search for a particular item. In this case, what we want to look for, not really a particular item, but a minimum value. First thing I want to do is comment out the code from before. First thing we're going to do is we're going to create a variable called min, and we're going to set it to 0. What we want to do is we want to return the position where the element is, so that we can then access it, rather than return the element itself. So what we're going to do is we're going to set our min variable to position 0. Then we're going to loop through the array list for int I equals 1, I less than numbers dot size plus I, if numbers get sub I is greater than numbers get min. Actually, we want to say less than, not greater than. Min is equal to I. And then when we're through, we can write system out println the minimum value in numbers is numbers get min, like so. We're assuming that the minimum value is found at position 0. And then for every other position from 1 through the end of the array list, if the value in that position I is less than what is in position min, then that value or that position becomes the minimum position. Min equals I. So let's compile the program, clear the screen, and run it. And the minimum value found was 0. And it's probably going to be just about every time we run. Oh, that time it was 2. I'll run it a few more times. The third time it's 1. We'll stop there. So of course it depends on what set of random numbers is generated for the array list, but generally it's going to be 0 or 1. This one time it was 2. Of course that all just depends. So that's just a common algorithm for finding a minimum value. Assign the first element or the first position as the minimum value, and then loop through the rest of the array list, and if a value you find is less than what's in the minimum or at the minimum position, then that new smallest value becomes the new minimum. We'll work an exercise at the end of the chapter where we find the maximum doing pretty much the same thing. So that wraps up our lesson on searching, and we're going to move to the next lesson where we talk about how to sort an array list using some very elemental sorting methods.